This video is a continuation of the video we did earlier where we're using the Turtle graphics library to plot some equations. And we're just going to continue with that here by doing a couple of additional ones, and we'll bring in the floor and ceiling functions first. So I'm going to use some of the same code that we had earlier. So this, let's go through it. We have a loop to generate the x and y coordinates for a function called floor and one called ceiling. So that will this will give me the opportunity to tell you what those functions do. So let's go ahead and get going here. We have to import the math library because those functions are part of the Turtle math library. And then we got the usual stuff here. We import the Turtle, and we do the get screen, and we do the shortcut so we don't have to type Turtle every time. We have a scale factor set to 40 right now. Now, what I'm going to do with this one is I'm going to generate a table for floor and ceiling with x, and x will go from a -10 value to a +10 value, but I'm going to use increments this time that are real numbers, 0.35. So that may and certainly will impact our ability to use the for loop further down. You've seen in the previous video that we are going to lay out the x and y axes just by drawing them with the Turtle graphics here, and then I'm going to set the pen size to 2 and raise the pen up in order to get ready to go ahead and make the plots. Well, the first thing I want, though, is I want to make a table that can illustrate what these two functions do. Okay, so let's put that down here, and I'll paste that in. So here is the table. So I will print the x, and I'll print the floor function for x and the ceiling function for x. And I can explain it better when I go ahead and print out the numbers, and I'll tell you what those functions do. So I will begin with my x values at -10, and I'm going to use a while loop this time. Now, the reason that I'm going to use a while loop is because I need to increment my value of x by a real number. So I could make the for loop work, but it's much easier just to use the while loop in situations like this. It's very straightforward. So here is the loop. Okay, we'll begin with x at -10. While x is less than or equal to +10, we will do all of those 4 lines repeatedly until x becomes greater than 10. So the way that you get the functions is to use the math library. So I have a variable called xFloor that I'll set to the math.floor function of x, and I've got a ceiling value, xceil, that will be the ceiling value of x. Again, we have to use the math dot in front of that. Now, the value for x is changing, like I said, by a small amount here, by 0.35. So in order to keep the numbers from running on and on and on over to the right, I'm going to use the round function to print out x. So x will always just have 3 digits to the right of the decimal. Okay, then I'll have some space, and then I'll print out the value for the floor, and then I'll put some more blanks here, and then I'll print out the value for the ceiling. So let's run the program, and let's look at the table that this produces. So I'll click Run, and I'll save the output. The turtle pops up. Don't want the turtle right now. So let's bring in the table part of this so you can see the table show up. Now, let me resize this a little bit, and let's look at the values for this. All right. So, and let's just start with this line right here. Okay, so -10, the floor for that is -10, the ceiling is -10. All right, well, that is not very helpful, is it? Let's scroll to the point where we're right at 0. Now, so here we have the value of x is -2, and then we cross over to a positive value of 0.15. The floor function is going to give us the whole number that is less than the value for x. Okay, so now let's look at these. Okay, 1.2. What's the integer value that's less than that? Well, it's the whole number 1. If it's 1.55, what's the floor? It's also 1. And if we look at 1.9, well, that's also 1. So this isn't a rounding operation. This floor function is giving us the integer value that is at the bottom of this range of numbers here. So any number that is 1 and a fraction, it could be 1.999, then the floor of that is going to be the integer that's below that value. Okay. Same thing, let's look at 2. 2.25, the floor is 2. But 2.95, the floor is still 2. So it does not round. It goes to the integer value that's lower than any of those values with fractions. Now the ceiling function does exactly the opposite. Okay, so let's go to 1.2. And there we go. So 1.2. The ceiling part of that is the next whole integer above that value. Okay, so that will be 2. Okay, 1.55. Okay, the next whole value is 2. 1.9, same thing, 2 over here. Okay, let's look at another value. Let's go like 6.1. Okay, 6.1. The floor of that is 6, but even though this is just 1/10, the ceiling part of that is 7. So that's what the floor and the ceiling functions do. And you may wonder, why would you ever want one of these things? But these functions do turn out to be useful for some applications. Now that you've seen what the floor and the ceiling do, and they work for negative numbers as well, right? So let's see, it's negative 8.25. What is the floor of that? Well, the floor of that is the next whole number that, and the negative numbers may kind of look weird when you do this, right? So what number is less than 8.25? A negative 9. Negative 9 is less than 8.25. Okay, so it is the integer, the next integer that is smaller than that. And the ceiling is going to be the next whole number larger. So in negative numbers, it does still work. Now, let's use our turtle graphics to plot these two functions. We'll plot the ceiling and we'll also plot the floor. Okay, let me rearrange this just a bit. As it turns out, I've got an extra line up here that prints the title. Okay, so I really should have put the code to do the table up there. So let me just quickly cut and paste that, and we'll put it up at the top. And that will keep it out of the area where we're doing our plotting with the turtle. Okay, so now let's put that up there. And now we can do the turtle graphics part of this. So we are getting ready to do the plot. So we need to prepare the turtle. So we have set the pen size to 2, we've picked up the pen, and we need to go to the starting point. All right, well, I know in this case it's easy, right? We want to go from -10 to +10, but we know also that that is in pixels, so the plot would be very, very small. So I'm going to multiply both the x-coordinate by the scale and the y-coordinate by the scale. And I'm going to set a dot here. I'm going to draw a circle for each of these points, and I'll make those points blue. So that gets everything set up. Now we need to go through the loop so that we can plot that. So we need to draw the curve. So let's put in the code to do that. All right, so now we are ready to draw the curve. We put the pen down, and this time we are using that while loop again. So the while loop is going to go from -10 to +10. And this time I'm just going to calculate the floor value. Okay, when I did the table up here, I did the ceiling and the floor, but I only want to plot these. And okay, I kind of lost my cursor there for a second. So we want to plot the floor function. So we'll calculate the value for floor. Okay, so x floor is math.floor of x. And then we just go with our turtle, and we draw the curve. And I'm going to put a blue dot at every coordinate, every set of coordinates. And when you're working with a while loop, you have to increment your loop control variable or you'll never get out of the loop. So I have to add my increment 0.35 to x, and then we go back to the top. So the while loop now will call on our turtle graphics to draw out the function, which is the floor of x. So let's run the program for that. We'll click Run, click OK, and here's our nice turtle canvas. So we draw the coordinates, and then here comes the floor function. So it's a step-like function. Okay, so let's go down here to 0 again, and let's recall, those plots, right? So as long as you've got a number, then that number right there is the value that's just above 1. So that the value, the floor of that will be 0. So these are fractions. These three dots here, those are all fractional values. And let's just even bring those back up again, if I can find them. Okay, so we'll bring that over here, see if I can get everything on screen. There we go. All right, so let's look at these three dots just to the right of the axis. So in this case, we're plotting this one right here. When x is 0.15, then the floor of that is 0. So you see it's plotted right there as the y value is 0. When the value is 0.5, the floor of that is 0. So that's how we get the second dot. And, oh my, I lost it again. Then the other one is when it's 0.85. The floor of that's also 0. Okay, so these three lines are from the table, and that represents these three dots along the x-axis right here. Now, let's add to our program so that we can also print out the ceiling function. So we'll reset the turtle. So we'll send the turtle to the starting point, and that's the same as before, right? So we want to go to the same place, but this time I want to put a red dot. So we'll make the ceiling function print out the coordinates as a red dot, and we'll have almost the identical while loop here. So let's place that here. And we're doing exactly the same thing, except we're computing the ceiling this time. Okay, so we'll compute the ceiling of x using math.ceil, and then we'll go ahead and plot them. So here's x times the scale value, here's the ceiling, x ceiling, times the scale vector, and the dots are plotted in red. And again, we're moving about the same amount each time for x. So now let's run the program, and we can watch the ceiling and the function, the floor functions plot. Okay, so we have the axes. Blue is the floor. Okay, then we'll go through the while loop, and we will see the ceiling function. Okay, so one's red, one's blue. And again, if you look back down here, then we had these values. The ceiling was, the floor was 0 for these. We had some value less than 1, but the ceiling of that is going to be above. It's going to be above the axis, so it's going to be one above that. So let's look at those numbers again. We're going to put them, let's put them right there. So here we have the floor is 0.15 is 0. That's the blue dot along the x-axis. But the ceiling is 1 for each one of those. So we get the red dots. So those three are 0. These three red dots will be 1. And then the same thing as we move over. That's the 1, the value for 1 here, and the value for 2. So this shows you a plot of the floor function and the ceiling function. So if you like steps, then you'll like this. All right, now let's move on to another example. Now let's switch to a couple of very common trigonometric functions, the sine and the cosine. And you know, well, that, okay, the value for x I'm going to choose is -10 to +10, and that's going to be in radians. But we know that the sine and the cosine values fluctuate between -1 and +1, so that's a common knowledge. So the range of the values for sine and cosine are going to be really small. Let's go ahead and let's print out a table of those. So here I've got the headings. We'll print x, the sine of x, the cosine of x, and I'll just put the loop in here to do that. And once again, since we're using values that are real numbers like 0.5, then I'd rather use the while loop instead of trying to force my for loop into doing this instead. So the while function, the while loop is easier to use in these examples. So x will begin at -10. It goes to +10 as we did earlier. And I'm just going to calculate the sine and the cosine. And again, we have to use the math library, math dot, and then the function sine x, math dot, and the cosine of x. Okay, so then we'll save those values in the variables sine x, cosine x, and then I'll plot them. And since these values can have a number of digits running along the x-axis to the right of the decimal, then I don't want to see all of that, so I'm going to cut this off. So I'm going to set the value of x, I'm going to round it to 2 digits, and I'm going to round the sine x value and the cosine x value to 4 digits to the right of the decimal. At the end of the loop, I'm going to add 5, or 0.5 each time. So what this will do is just to produce the table showing us the values of sine and cosine between -10 and +10. So if I run the program, we can see that table. All right, so we'll bring we also get the canvas for the turtle that always shows up. We'll get to that shortly. But here's the table. So you can see that if we have these values, and again, remember this is radians. These functions typically use radians instead of degrees, but you can convert them to degrees easily. So here we have the values, okay? The x is minus 10, then we have the sine and the cosine for that. And if we just move up, here's the 0, so the sine is 0, cosine is 1, so we know that. And so on. So here's just a whole list of those values, but you can see that the numbers are all less than 1. Right? So I guess, well, it could be 1 here, but they're always going to be 1 or less than 1. So if we want to plot these, then we need to multiply the scale by a pretty big factor. So that's why I have set the scale up here to be 40. So we want to multiply that, so that'll make our plot much bigger. If it were less than 1, it would be almost a straight line. It'd be really hard to see it. Now, to plot this, the same thing as before, we'll just draw the axes for x and y. We'll prepare the turtle. We'll set the drawing pen size to 2, and we'll pick up the pen. Then we will go and put in the code to draw the curve. Well, in this case, we can redo the while loop, but we need to prepare the turtle. We need to make sure we put the turtle at the starting point to begin with. So let's continue to put that preparation code here. So we'll send the turtle to the starting point. All right, so I want to go to 10 times the scale. So that's the value for x that I want to use. And then I want to have the y-coordinate to be the sine value. So I'm going to take the sine of negative 10, and whatever that number is, I'll multiply it by the scale. Now, this just gives me the first point. That's where the turtle goes to begin its drawing path. Then I want to draw some dots, blue dots along the way as we trace out the curve. So then we just need to put the loop here that does the actual drawing. So it's almost the same while loop as we had up above. And this time, instead of making a table, then we'll draw a curve. So x goes from minus 10 up to plus 10. I'll calculate the value sine x given x, and then I'll just plot those two numbers. We'll plot x times the scale and the sine x times the scale. And for each of the set of coordinates, x and y, I want to print a dot. Then we'll increment by 0.5 and go to the next set of coordinates along the way. All right, so this should generate a nice pretty sine wave. So let's run the program. And let's watch our turtle draw that out. So here we have the canvas, we have the coordinates, and there's a blue sine wave. Pretty neat, isn't it? So for each of the coordinates, this is minus 10 over here, x is minus 10, and y is whatever that value is. Then you can see we just go to minus 9, minus 8, and work our way across. So we produce a blue sine wave. Now, let's also plot on the same graph, let's plot the cosine. So to do that, we just need to prepare the turtle once again so that we can draw the curve. We need to move it to the starting location, and I'll do that by pasting the code here. We'll pick up the pen, we'll go back to the origin, and then we're going to go to this location here. All right, so once again, we're starting at x is minus 10, but this time the y-coordinate will be the cosine value. So I'll take the cosine of minus 10 times the scale. So that's the y-coordinate, and this is the x-coordinate for the very first dot, our first set of coordinates. And to trace out our cosine curve, then we do almost identical to what we did up above with the sine wave. And I don't think I got the right stuff right there. So so now I've got the correct code. So we have prepared to go do the cosine curve. Okay, so we have moved to the starting location. We've set the dot color to red. And then when we go through the while loop, we're calculating cosine. Okay, so everything else is the same. We'll calculate the cosine, and we will plot the cosine as the y-coordinate here, and the x-coordinate is still the same as before. So now we will have a red cosine curve. Okay, so we run it. And here we watch the turtle draw out everything. So we'll see the blue sine wave. Then we'll see the red cosine wave. Okay, and we saw a little extra there, didn't we? So see, look at this line, that black line. I failed to pick up the pen when I moved over to the starting point. So let's go fix that. Okay, I made that little fix, so let's run this one more time. And here we go. We have the turtle drawing out all of the curves. Cosine, well, that's sine. Blue is sine. Red is cosine. All right, now if you wanted to, you could increase the scale in the y direction to make this even more pronounced, but that's a pretty reasonably good-looking sine wave and cosine wave that we have there. The last example I want to show you is a different way to plot the sine and the cosine. Now in this example, it's almost identical to what we had before, so we still have the table at the top that prints out the table of sine and cosine. But instead of printing two separate curves, I've combined them. So notice in the while loop, I have also changed the range here. So I'm going to go from minus pi up to a little over plus pi because I want it to stop at plus pi. But I'm going to set the x-coordinate, sine of x, here to the math.sine of x. And I'll set the y-coordinate to the cosine of x. So when I plot them, I'm going to be plotting the sine x as my x-coordinate, and I'm plotting the cosine of x as the y-coordinate. And I've made the color blue, and I'm incrementing this time by 0.314 each time. So let's run the program, and let's see what kind of plot we get this time. So I'll click Run, and we'll watch the turtle draw the axes. And now we get a circle. So if you have the x-coordinate as the sine and the y-coordinate as the cosine, then you get a nice circle here. Okay, well, that kind of concludes a brief survey of some of the math functions that the Python library holds, and there are a number of them, as I've mentioned. So if you are interested and you need to have some math functions, if you can think of it, then it's probably out there in the math library. All right, well, let's stop the video here.